Hey, hey you. That's right. I'm talking to you with the pencil. Put the pencil down now. You don't learn anything copying off of me. Watch the video. Learn how to do the problem that you did not know how to do, and then go back and try to do it yourself. Better yet, wait a little while after watching the video. Do some other problems, and then come back and try to do the problem a little bit later. If you can still do it by yourself, you know what you're doing, and you'll probably be fine tomorrow or the next day. But if you can't, you better watch the video again, practice some more, repeat, rinse and repeat. Put the pencil down. Okay, this is yet another review. Nth roots, fractional exponents. Let us begin. You will not be allowed to use a TI-30 type calculator. 4-function calculator should be okay. Alright, simplifying this guy. Well, you see it has a 0 power. Just remember that this 0 power, anything to the 0 power is 1. But that 0 power only applies to the xy here. It doesn't touch the -8. So I'm just going to have -8 for the answer. Looking at number 2, I have to do all this stuff to the 3rd power. Now, -3 to the 3rd power is -27. By now you should have memorized that 3 to the 3rd power is 27. And when you do a negative number to an odd power, it stays negative. With the variables, I have to multiply those. So 2 times 3 is 6. So I will have a to the 6th power. And then, of course, I have b to the 3rd power. Am I going to take this -27 and drop it down to the bottom because it's negative? No, I will not. You don't drop down negative numbers. Only things with negative exponents. This is not an exponent, so this stays right where it is. Look at number 3. Okay, let's multiply because we have a power raised to a power. So in the numerator, we're going to have x to the -9 power. In the denominator, we have 2 squared, so that's 4. And then that's x squared. Now, this is going to move. If you have a negative exponent, you are on the wrong side of the fraction and you must come down. So, on the next step, this is going to become 1 over. See, my 4x squared stays right where it is. But this x to the -9th power drops down and becomes x to the 9th power. When I multiply these together, I add the exponents. So that'll be 11. So my final answer for number 3 will be 1 over 4x to the 11th power. Just like that. Look while I'm over here. Alright, I'm wasting time. Okay. Number 4. There are no exponents on the parentheses, so I'm just going to start multiplying stuff together. So 2 times -3 is -6. A to the 4th times a to the -4th. Well, look, that's a to the 4 plus -4 once I add. But that's a to the 0 power, which is just 1. So basically, these cancel each other out. Alright, I don't need to write times 1. So no more a's. The a's are all gone. Don't even bother writing a to the 0 power down. Oh look, same thing's going to happen with the b's. Okay, 2 plus -2 is 0. B to the 0 power is just 1. So you don't need to write that down. So look at that. The answer number 4 is simply -6. Genius. Number 5. Alright, the cube root of 192 x to the 9th power. Let's look at the chart. Cube root. 192 is not on the list. So I need to see if any of these numbers will divide into 192. How about 64? Oh yeah, look, that works right away. Okay. So that means 64 times 3 is 192. So I can break this up as the cube root of 64 times 3. I will put the 64 in pink because that can be simplified and brought out. And I'll write the 3 in blue because that is not going anywhere. X to the 9th power. For the variables, you really want this power to be divisible by the root. It already is, so I'm going to leave it alone and just color it pink. Now everything in pink is going to simplify and come out front. So cube root of 64 is 4. So the 4 will come out front. The cube root of x to the 9th power, I just divide 9 divided by 3. So that'll just be x to the 3rd power. Now this blue 3 is going to be stuck here under the radical. So I'm going to have the cube root of 3. Don't forget the little cube root. But that would be your answer to number 5. Okay, how about number 6? Alright. The 4th root of 30,000. Now looking at the table, 4th root, I can do the 4th root of 10,000. So let's see what I can do with that. So let's break this down. I've got that 3. Alright, that's not going anywhere for a while. Okay, fine. So I've got the 4th root. I can do 10,000. I saw that on the chart. So 10,000 times 3 will be 30,000. Okay, so there you go. And now a to the 12th power, I like it the way it is. 12 is divisible by 4. So I don't have to break this apart. I'll just color it pink to remind me that it's coming outside in a minute. Now everything here in pink is going to come outside of this radical. So the 4th root of 10,000, 4th root of 10,000 is 10. Okay, so I'm going to have 10. The 4th root of a to the 12th power is a to the 3rd power. Why? 12 divided by 4. That's what you do. Now everything here in blue is going to stay like it is. So I'm going to have the 4th root of 3. Now that 3 in the front that was there right from the beginning is still there. It is multiplying. So that's why my final answer is going to be 30. Alright, 3 times 10 is 30. A to the 3rd power, 4th root of 3. So that is your final answer for number 6. Number 7. Alright, once again I'm going to temporarily leave this stuff out front. So I've got negative 5 b to the 3rd power. So let's see what I can do with this stuff on the inside here. So I've got the cube root. Now 125 I do believe is on the chart, right? It's a perfect cube. It's going to give me 5 later. So I'm going to go ahead and write this in pink right now because this is already ready to simplify. When you take the cube root of a negative number, it's simply a negative number. That's all. Now, I need this 7 to be divisible by 3, the root. it is not divisible by 3. So this time I need to split this up. The first number below 7 that's divisible by 3 is 6. So I'm going to start off writing b to the 6th power. That will divide. How many b's will be left over? Just one, alright, just b. Together, these b's would still be worth b to the 7th power. Now everything here in pink is going to simplify and come out. The cube root of negative 125 is simply negative 5. Right? Remember, cube root of 125 is 5. Because it's negative, it's a negative 5. With the b's, I'm going to get b squared from this, because I'm doing 6 divided by 3, which is 2. So that's it for the pink stuff. Now, this blue b is still going to be under the radical, so I will have the cube root of that 1b. And this stuff over here is still there as well, so negative 5b to the 3rd power. The stuff out front is multiplying. So in the end, I'm going to multiply all this together. So negative 5 times negative 5 is positive 25. b to the 3rd times b squared is b to the 5th power. And then I've still got my cube root b. So this will be your final answer for number 7. Alright, number 8. Fourth root of 810. Now, fourth root, 810 is not on the list. Notice that 81 is on the list. Alright, I'm mentioning that because clearly 810 is 81 times 10. So let's do that. So as I go to split this up, alright, I've got the fourth root. And like I said, let's break up 810 as 81 times 10. Now, I need these powers to be divisible by 4. Neither one of them are. So I'm going to have to split them up. The x's I can split up into x to the 4th power, that's divisible, and x squared, alright, for a total of 6. Then the y's, the first number below 9 that's divisible by 4 is 8. So I will do y to the 8th power. And that's going to leave 1y left over for a total of 9. So everything in pink is going to simplify and come out. Fourth root of 81, alright, fourth root of 81 is 3. So this 81 is going to become 3. The fourth root of x to the 4th is just x. I'm dividing. 4 divided by 4 is 1. You don't need to put the 1. When I do the fourth root of y to the 8th power, I'm going to get y squared, because I divide 8 divided by 4 is 2. So that's all the pink stuff. Alright? But everything here in blue is going to stay under the radical. So I will have the fourth root of 10 x squared y. And that will be my final answer for number 8. Alright, let's take a look at number 9. Well, notice that both of these are fourth roots. Since they're both fourth roots, I can divide anything that will divide. There's no number in front of the x, so I'll move on to the x. The x's will cancel. This x in the top is going to cancel out one of these x's. Alright, so let me start building the denominator here. So I have the fourth root. I have 6,561. So this is going to be x to the 4th power, because this x in the top cancels out one of these 5x's, leaving 4 behind. Okay, similarly with the y's, these two y's are going to cancel out two of these y's. And so that's going to leave y to the 12th power, because two of these will be canceled out. Notice everything in the top just canceled out, so I'm just going to put a 1 up here kind of as a placeholder. Now, let's see if 6,561 is on the 4th power list. 6,561. The 4th root of 6,561 is 9. So all of these things I can do the 4th root right now. So if I had known ahead of time, I would have made all these pink, because all three of these can simplify and come out. The 4th root of 6,561 is 9, so I will have 9. 4th root of x to the 4th power is just x, because I'm doing 4 divided by 4, is 1. And the 4th root of y to the 12th power is y to the 3rd power, because 12 divided by 4 is 3. Alright, and this will be the final answer. A common mistake is to not put the 1 and just put 9xy to the 3rd power. So don't do that. This leftover stuff is in the denominator, so you have to show that this stuff is in the denominator by putting a 1 over it. So that's number 9. Okay, number 10. Both of these are square roots, so I can go ahead and multiply this stuff together. Let's start with stuff on the outside. 6 times 3 is 18, so I've got that. And I've got the y, so 18y. Now I'm going to put all of this under one radical. So I've got the 5 under there with nothing to multiply by it, so that's still going to be a 5. X times x to the 4th power is x to the 5th power. Y times y to the 3rd power is y to the 4th power. And then I've got z with nothing to multiply by it, so that's just going to be z. Alright, now let's break things down like we have done before. So first of all, the 18y, that's not going anywhere. It's just going to sit there. Now, let's see, so square root. 5 is too small to break apart. I mean, it's a prime number anyway. So that 5 is just going to have to stay blue, and it's not going anywhere. Now, please understand, as I deal with these variables, that a square root is understood to be 2. It's a second root. Alright, it's understood. We don't write the 2, but I'm just emphasizing it because I need these exponents to be divisible by 2. So for that reason, I will split x to the 5th power up as x to the 4th power with 1 extra x for a total of 5. Now y to the 4th power is already good to go because 4 is already divisible by 2. So I'll just put it in pink like that. Z, it has an exponent of 1, but I can't break up a single z, so that guy, like the 5, is just going to have to stay blue and stay under the radical. There's no way to simplify that any further. So everything I've shown here in pink is going to simplify and come out of this radical. So let's do that first. The second root of x to the 4th power is going to be x squared. Similarly, the square root of y to the 4th power is going to be y squared. Alright, those are the only two pink things, so that's done. By the way, I recommend using colors like I do. I haven't really seen almost anybody doing it, but I think it will help you, especially if you've been making a lot of mistakes. Anyway, the blue stuff is going to stay under the radical, so 5xz. Okay, now I've still got this 18y out in the front, and ultimately that is multiplying by stuff. Now the only thing I can really multiply are the y's. Alright, they're the only things that are the same. So the final answer will be 18 x squared, just brought that down, but y times y squared is y to the 3rd power, just collecting these together. And then I've got my square root of 5 xz. So that will be your final answer for whatever problem that we're on that I already forgot. 10. That was number 10. Alright, how about number 11? If I were you, I would collect the numerator into one radical first. They're both cube roots, so I can go ahead and multiply the stuff on the inside and make one big radical. That's what I would do. So I'll have the cube root. 6 times 9 is 54. Okay, x to the third times x squared is x to the 5th power, because we add those exponents. Y times y to the 6th is going to be y to the 7th power over, and for now I'm just going to copy this down. So it's over the cube root of 2xy to the 3rd power. Now notice the smaller things are in the bottom this time. So because the roots are the same, I'm going to go ahead and divide these things. But this time the remaining things will be in the top, not in the bottom, not in the denominator. So anyway, so check it out. 2 goes into 54 27 times. Okay, I'm just saying that 54 divided by 2 is 27. So that's going to become 27. This x is going to, I should probably build this as I go along. Alright, so this is, I'm going to record the results up here. So the cube root, so the 2 divided into 54 and made a 27. This x is going to cancel out one of these x's and leave x to the 4th power. All three of these y's are going to cancel out 3 of these y's up here. So that's going to leave y to the 4th power. Okay, so notice everything in the denominator canceled out. Do I need to put a 1 down here as a placeholder? No. You only have to do that when the 1 is in the numerator. We don't write down a 1 in the denominator. So we have this. Now let me colorize it and break things apart as needed. I'm doing the cube root. Now, by now you should have memorized that 27 is a perfect cube. Alright, the cube root of 27 is 3. I'm just mentioning that because that's why I'm going to make the 27 pink, because it will simplify. I need these 4's to be divisible by 3. So I have to split these variables up. So x to the 4th power will become x to the 3rd power times x. Similarly, y to the 4th power will become y to the 3rd power times the extra y. So once again, everything here in pink is going to simplify and come out of the radical. So cube root of 27 is 3. Cube root of x to the 3rd power is x. Cube root of y to the 3rd power is y. That takes care of the pink stuff. Now everything in blue is going to stay under the radical right where it is. I'm talking to you, x and y. So this is going to be the cube root of xy. So this will be your final answer for number 11. Number 12, please watch very, very carefully. This is one of those ones that half the class tends to get wrong. And the mistake that students make has to do with this negative sign. Notice that the negative sign is not included in parentheses. Okay? If the negative sign was inside of parentheses, then this 2/5 power would include the negative sign, and when we rewrite this in radical form, the negative sign would be in there and it would be involved inside the problem. But because there are no parentheses, that means this negative sign is going to just stay out front. when I do the 2/5 power, I'm only doing the 2/5 power to the 16,807, not the negative sign. So I'm going to go ahead and rewrite this in in radical form, because I remember that the numerator will be the power and the denominator will be the root. So in radical form, right, the root is 5, so that means the 5th root is what's happening. So the 5th root of 16,807, and then power of 2. So I will do all this to the 2nd power. Notice this negative sign stays out front. It's not in here. So let's go ahead and do the 5th root of 16,807. Looking at the table, 5th root of 16,807 is 7. So that means I'm going to have negative 7 squared. Alright, all this stuff in here just became the 7. Now here again, please understand this, because this negative sign is not in the parentheses, when I'm just only going to square the 7. The negative is going to stay there. It's not going to turn positive. So of course 7 squared is 49. But the final answer will be negative 49. Alright, a common mistake is to go, oh, I'm squaring things, so it's going to turn positive. No, the negative is not inside the parentheses. It is going to stay out front. Alright, and just to be even extra clear, even if I didn't have these parentheses here at all, say if I just had this, just negative 7 squared. Alright, let me just make it even more. If I had negative 7 squared like this, this would be negative 49, not positive 49. Alright, unless I have parentheses, this squaring business only happens to the 7. The negative sign stays. Alright, I hope I emphasized that enough. Let's move on to number 13. Okay, number 13. There's different ways to think about this, but here's the way I like to do it. When you have a negative exponent, that means everything needs to drop down to the denominator. Okay? Now, one more thing though, one more time. This negative sign is not, there are no parentheses. So please, this negative sign is just going to sit out front. Nothing's going to happen to it. It'll be there the entire problem until the end. Okay, so just focus on the 3,125. So I've got a negative power on it. So that means I have to take this and drop it down to the denominator. So that's why I'm going to have 1 over. So that negative sign, it's right there. So once I drop it down, I'm going to have 1 over 3,125 to the 1/5 power. Now, if I go ahead and write this in radical form so I can just see what I'm dealing with. Okay, I've got 1 over 1/5. This 5 is a root. So that means I'm dealing with the 5th root of 3,125. Okay, so hopefully this is on the chart. So let's see. The 5th root of 3,125 is 5. So that means I'm going to have negative 1 over 5. And that's it. So the final answer is negative 1/5. Notice that this negative sign, because it's not in parentheses, it just stayed out front the entire time. I just brought it down. So get used to that. Okay. Alright. Please understand this negative is not going to make this will not be a negative number. A negative exponent, as we've seen many times, is just going to drop this down to the bottom of the fraction. So I'm going to have 1 over 36 to the positive 3 over 2 power. I just drop it down because it's a negative exponent. Now I will use my radical form to simplify this. So I'm going to have 1 over, alright, 2 is the root, 3 is the power, so that means the square root of 36, alright, the second root, and then to the third power. Alright, we know this by heart. Square root of 36 is 6. Alright, so then I've got 6 to the third power. Now I'm pretty sure 6 to the third power is 216. But to be sure, I will check 6 to the third power on the chart. 6 to the third power, in fact, is 216. So there is your final answer for whatever problem this is that I've already forgotten what problem we're on. 1 over 216. That was number 14. Okay? Let's see, how many more of these we have? Alright, 3 more. Okay, number 15. When you multiply like bases, you add the exponents. So we are going to be doing x, and we're doing 1/2 plus 1/3. So I will just do this off to the side, as I often do. So 1/2 plus 1/3. When you add, you need like denominators. So if I multiply by 3, I'm going to get 6. If I multiply by 2 over here, I'm going to get 6. So I need the common denominator. So I'm going to have 3 over 6. Alright, plus 2 over 6. 3 plus 2 is 5, so that's going to be 5/6. Okay, so that's what you get. So that's what's going to be happening right here. So that's why I'm going to have x to the 5 over 6 power. Now, should I write this as 6th root to the 5th power? Alright, do radical form like you've seen me do sometimes, I guess? No. Because the original problem is in exponent form, I should definitely leave my answer in exponent form. So, boom. That's number 15. Done. Okay, let's move on. Number 16. Okay, good times. I see that negative exponent. If I were you, first thing I would do is I would move this up into the numerator. So let's recopy. First, in blue, I'm going to write down everything that's not moving. So I've got my x, I've got my y to the 1/2 power. That's not going anywhere. In the bottom, I've got my x to the 3/4 power. Those three things stay where they are. But this y to the -2 power is going to come up and become y squared. If I were you, that would be my first step. Now, let's do the x's and the y's as sort of like two separate problems. When you do the x's, okay, when you look at these x's, this is like x to the 1 power, okay? In fact, maybe I'll make my lasso go include that. So I'm doing my x's, and when I do my x's, I'm doing x to the, when you divide, you subtract these powers. So I'm doing 1 minus 3/4 right now. Okay? And I'm also going to do the y's. Okay? But when you multiply, you add the powers. So when I do the y's, it's going to be like y to the 1/2 plus 2. So I'm subtracting the x's, exponents, because I'm dividing, and I'm adding the y powers because I'm multiplying. So all I have to do is do this subtraction and addition, and that'll be it. So, like denominators and stuff. So off to the side, when I do 1 minus 3/4. Okay? First of all, this 1 is like 1 over 1. I need like denominators, so I could just multiply by 4. Okay? That would give me 4 over 4 minus 3 over 4. 4 minus 3 is 1, so that's 1/4. Okay, so that's what's going to happen with the x's. That's why the x's will become x to the 1/4 power. Okay, now similarly, let's do the y's. So off to the side, if I do 1/2 plus 2, alright, you can think of that 2 as being like 2 over 1. I need these denominators to be the same, so I can just multiply the top and bottom by 2. So that is going to give me 1 over 2 plus 4 over 2. 1 plus 4 is 5, so that's going to give me 5 over 2, 5 halves. Okay, so that is what's happening with the y's. So my y's will be y to the 5 over 2 power. And that came straight from this. And that's it. This will be your final answer. Okay, that was number 16. Alright, I think this is the last problem. Okay, number 17. So I need to do the 1/2 power to everything. If I were you, I would temporarily, because I've got the 16 here, just think 16 to the 1/2 power. Just stick it on there. Now with the variables, you multiply. Okay, so 10 times 1/2 is 5. Alright, I mean it's half of 10 is 5. I mean if you really need to do it out, it's like 10 over 1 times 1 over 2. That's 10 over 2, that's 5. But I'm hoping you don't have to do that. Anyway, the y's. I will have y to the 1 over 6 power. Alright, and again, I'm doing 1/3 times 1/2. When you multiply straight across. So 1 times 1 is 1, 3 times 2 is 6. So that's where I'm getting 1/6 from. This is almost the answer. But let's go ahead and deal with 16 to the 1/2 power. Well, just understand that 16 to the 1/2 power is the same thing as the square root of 16. And of course the square root of 16 is 4. So I will have simply 4 x to the 5th y to the 1/6 power. And that will be your final answer. Alright, and it's the square root because this 2 is the root and the second root is the square root. Okay, that is it for this video. If I were you, I would make sure I can do every single problem on this paper by myself. And it kind of doesn't count if you just watch the video. And even if you did it yourself, if you did it immediately after watching the video, you know, like 60 seconds later, that's too fresh. It's almost like copying off of me. It's not quite as bad. The trick is make note of any problems that you got wrong and make sure that you can do them several hours later or maybe even the next day. If you can do them later by yourself and still get the right answer, that's when you know that you really know what you're doing. Alright, good luck guys. I will see you on the next video.